For problem number 13, we're going to use the formulas x equals r cosine theta and y equals r sine theta. And to make sure that I don't make any mistakes, I'm going to make sure that my calculator is in radians, because when they give me negative pi over 5, I want to make sure that I'm in radians. So we get x equals 4 times cosine negative pi over 5, y equals 4 sine negative pi over 5. And so my x value is 3.24. My y value is going to turn out to be negative 2.35. We are going to look for two different ways to figure out where this point is on the polar coordinate system. And so the first thing we need to do is we need to find r, and we're basically going to do the Pythagorean theorem in order to find r. So we have 89 equals r squared. Square root it. 9.4 equals r. Then we are going to do the tangent, and the inverse tangent of y over x, so we're going to do negative 5 over negative 8, turns out to be, make sure we change our mode back to degree, and that's going to be 32 degrees. But 32 degrees is not in the third quadrant, so I'm going to have to add 180, and so that's going to be 212 degrees. However, they asked for two answers, and they said theta has to be in between 0 and 360, so we're going to have to find out what the other one is. Well, the other one uses the angle on the opposite side, which is the one we'd originally found, which is 32. But instead of going towards 32, we're going away from 32. So the 9.4 turns out to be negative 9.4. For problem number 15, I'm going to start out by distributing the r. And so I got r sine theta minus r cosine theta equals 8. Now, when we were doing the problem earlier, we knew that r sine theta was equal to y. That's how we got the y coordinates. And r cosine x, or theta, was equal to x. And the 8 just stays as an 8. Alright, in this next problem, we're given x squared plus y squared. And anytime I have x squared plus y squared, I'm going to change that to r squared. And we're going to change y to be 6 sine theta r sine theta equals 0. Now when trying to solve this for r, what I'm going to do is I'm going to subtract the 6r sine theta to the other side, and then because they both sides have r in it, I'm going to divide by r, and so r equals negative 6 sine theta. For problem number 17, they're talking about the point 50. Well, in the point 50, if I do 5 squared plus 0 squared equals r squared, r is going to equal 5. Now, we shouldn't know without doing much work that over here is 0 degrees or 0 radians. So my answer for where is 50 on the polar coordinates is at 50, whether that be degrees or radians. for this next problem, we can't use x squared plus y squared because of that 3. So I'm going to do 3r cosine theta squared plus r sine theta squared equals 3. So that would be r squared cosine squared plus r squared sine squared equals 3. So these both have an r squared in common, so I'm going to factor it out. Now if I'm trying to get r by itself, what I'm going to do is I'm going to divide by the whole parenthesis. So at this point, to get rid of the squared, we are going to square root. R equals plus or minus the square root of 3 over 3 cosine squared theta plus sine squared theta, and that's the answer for number 18. Alright, I really like number 19 because if I know that r sine theta is the same thing as y, we simply have y equals 4. Alright, for problem number 20, whenever I see r theta and I need to transfer this into rectangular form, I need an r, so I'm going to multiply both sides by r. So this will be r squared equals r sine theta. Now r squared is the same thing as x squared plus y squared, and r sine theta is the same thing as y. And that is rectangular form. One more, we can do the exact same thing. We're going to multiply both sides by r, so I got r squared equals, this time it's 8r cosine theta. Well, r squared is the same thing as x squared plus y squared. R cosine theta is the same thing as x. And since that's the end of polar, this is a good time to stop, and we'll do chapter 5 in the next video.